use the graph of y equals f prime to answer the questions about the function f. This is graph of f prime, and we are answering about the function f. Okay, this is derivative graph and we are answering about the function. So in part A we got the question on what intervals is the graph of f increasing or decreasing. Okay, so look at this graph. So this is f prime graph. Now let's make a sign chart to see where the function is increasing or decreasing. Okay, so here is the domain, and let's look at this graph. This is f prime graph. F prime, by the way, that is 0 at -4. So at -4 f prime is 0. To the left of -4, the graph f prime is, this is f prime graph, is above x-axis, means positive. Again it's 0 here, that's 2. So at 2 this derivative is 0, but in between -4 and 2 still is above x-axis, so still plus. And here 2, so it's a 6. Oh, there's one more, 6. So let me just graph, make it longer to include this 6. Okay, 6 somewhere, does not have to be exact. At 6 derivative is 0, f prime is 0, but in between 2 and 6 the graph is below x-axis, that means negative. Again 6 and past all the way, that's positive. Okay, now we know that when derivative is positive the function is increasing. Positive means function is increasing, decreasing, increasing. So we want to write f is increasing on, increasing, this is negative infinity all the way to positive infinity. So we can go negative infinity all the way to 2. If you like, you can go from negative infinity through -4 and -4 to 2, or we can do all the way negative infinity through 2, and where 6 through infinity, and decreasing here. F is decreasing on, okay, here because the derivative is negative, or the graph is below x-axis, 2 to 6. Okay, in part 2 we need to find the x values at which f has a local max and min. Okay, that should be pretty simple since we already have the sign chart. So it's increasing, again increasing, so this is nothing, to increasing, then decreasing now. So we got increasing, decreasing means local maximum. So local maximum at 2. Decreasing, then increasing. So we have this situation around 6. So local minimum. And we are only asked to find the x value. So local minimum at, okay, I can have 6. Local maximum, I could have written local maximum first. Okay, there is nothing wrong. Local maximum at x equals 2. Okay, now the third question, on which interval is the graph of f concave up or concave downward? Again we need to do sign chart for second derivative. Okay, concavity means second derivative. And note that f prime is 0 where at the turning points, like this one or down here, here and here. These are turning points, at the turning points of first derivative. When we have a graph of f, the turning points at turning points of f prime is 0. So for f double prime, 0 means turning points of f prime. F prime is 0 at the turning points of f prime. And let's look at the graph of f prime. So this is graph of f prime, and we can see that it is turning here, so -4. So that means second derivative is 0 at -4. And again here, that means 0. So this is at -4, at 0 we got second derivative 0. Second derivative means derivative of this function. This function is y prime or f prime, and its derivative means second derivative. And again here, that means 4. Second derivative is 0. So second derivative is 0 where? -4, 0 and 4. So let me point out -4, 0 and 4. -4, 0 and 4. Now we need to see if second derivative is positive or negative. Okay, what happens is when first derivative is increasing, first derivative graph increasing, going up, means second derivative is positive. If first derivative graph is decreasing, something decreasing means that derivative is negative. Okay, so let's go up and see. Look at this graph. So this graph is going down. That means for this portion, second derivative is negative, going down. Now here from -4 to 0 is going up. This graph is f prime going up, means second derivative is positive. From here all the way down here, that means 0 through 4 is decreasing. That means second derivative is negative. From 4 all the way, it's now going up, means second derivative is positive. Okay, second derivative because this is already derivative. So we got negative, then positive, then negative and positive. So I would like to write down the sign. So we got negative, then positive, then negative and positive. So second derivative negative means the function is concave down. Positive means concave up. Negative means down, up, up. So let's write that in words. F is concave up on some intervals and concave down. F is concave up on up, so -4 to 0 and 4 to infinity. F is concave down on -infinity through -4, and here 0 through 4. Do not use union sign. Okay, some people write, but that's not correct. 0 through 4. Okay, that's it for part 3. In part 4, state the x coordinates of inflection points. Inflection points means, and we have to only do x coordinate, where the concavity changes. Okay, the curve changing from concave up to concave down and vice versa. As we can see at -4, on the left of -4, concave down, concave up. So x equals -4 is the x coordinate for inflection point. Again, concave up, down. So this is another, and down, up. So this is 4 as well. So there are 3 x coordinates at which we have inflection points. Okay, final